Limiting reagents. Sometimes when we have a chemical reaction that occurs, there's more of one reagent than another reagent. And so one reagent gets all used up and the other reagent is left over. Same thing happens, for example, when you're baking a cake. So if you're baking a cake, you tend to buy a dozen eggs and you look in the cupboard and you've only got 1 cup of flour. So when you're baking the cake, you're only going to bake enough using the 1 cup of flour, and you'll have excess eggs left over. So the same with a chemical reaction. You'll have too much of one reactant, and the limiting reactant or limiting reagent is the one that really limits how much of the product is produced. So in this example, in an experiment, there was 100 grams of hydrogen gas and 100 grams of chlorine gas, and they reacted in a sealed container. They both combined to give hydrogen chloride gas. So the first thing you'd have to do would be to write an equation for that. So after the reaction is complete, you are to calculate the masses in the container of hydrogen, chlorine, and hydrogen chloride. So this would be the equation that you'd write. H2 gas reacts with chlorine gas to produce 2 moles of hydrogen chlorine. So to work out the moles of hydrogen gas, first of all you'd have to write the mass that you know that you're given, which is 100 grams, and divide it by the molar mass of hydrogen, which is 2. And that equals 50 moles of hydrogen gas. Then you'd have to work out the moles of chlorine. So the moles of chlorine gas is 100 grams, because you're given 100 grams, divided by 71, because that's the molar mass of chlorine gas that we got from the periodic table. And that equals 1.4 moles of chlorine gas. So that's a lot less. You've got a lot less of the chlorine gas than you do of the hydrogen gas. You've got well too much hydrogen gas. So the chlorine gas is the limiting reagent. This means that all of the chlorine gas is used up. You've got none left in the enclosed container, and there is a lot of hydrogen gas left over that is not reacted. So let's try to find out first of all how much hydrogen gas is left over. So it's 50 moles minus 1.4, because you're only reacting 1.4 of the hydrogen gas, and that equals 48.6 moles of hydrogen gas left over, unreacted in the container. So there's the equation again. So the next step is to calculate the mass of hydrogen chloride produced in the container. So the ratio of hydrogen gas to hydrogen chloride is 1 to 2. This means that 2 moles of hydrogen chloride are produced for every 1 mole of hydrogen gas. To find the moles of hydrogen chloride, you have to go 2 from the ratio of, in the equation, 2 times 1.4, you got that from working out how much chlorine is reacting, equals 2.8 moles. So 2.8 moles is the moles of hydrogen chloride gas that's produced. So now let's find the mass of hydrogen chloride, and this is from the molar equation. So 2.8 mole that you just worked out times it by the molar mass of hydrogen chloride, which is 1 for hydrogen, plus 35.45 for chloride, and that equals 102.06 grams of hydrogen chloride gas. So in this sealed container, what you end up with is hydrogen chloride gas and excess hydrogen left over, and the limiting reagent is the chlorine gas.